NAJIHA. I will tell a little story about this task. Conductive heat transfer. It is the transfer of heat through the excitation of molecule in a material without motion from the bulk of metal. The objective we set is to show the temperature distribution along the heat transfer surface, fin and pin in free and forced convection. In this assignment, we have used Solidwork software and have sketches and analysis, fin surface and pin surface. The reason why we use the fin surface is because it is a expanded surface designed to enhance heat transfer rate for a fixed surface temperature, or a lower surface temperature for a fixed heat transfer rate. Meanwhile, the reason why we use the pin surface is because the large surface area improves the cooling performance.
My name is ZAHIM SUKAIRI. So I will explain about the drawing one. So we use width for 40 mm, length 40 mm, and height we use 15 mm. So the gap between fin we use 2 mm, and the fin size we use 2 mm too. And then heat transfer surface we use fin type. For material we use alloy aluminium, and the reason why we choose this design is fins are surfaces that extend from an object to increase the rate of heat transfer to or from the environment by increasing convection. So next I will explain for drawing 2 also. For the length and the width we use 40 mm, and height we use 2 mm, and the gap between fin we use 8 mm, and the diameter of the fin we use 5 mm. So the heat transfer surface that we use is pin type, and then the material we use alloy aluminium. And the reason why we choose this design is pin type surface are used to increase heat transfer from heated surface air.
My name is AHMAD ZIKRY bin MIDIN. Simulation of drawing 1. For heat power 1, load details, entities, 1 phase, heat power value 50 watt. Temperature 1, entities 1 phase, 370.3 Kelvin. For temperature 2, entities 10 phase, temperature 349.6 Kelvin. Heat flood 2, entities 10 phase, heat flux value 1500 watt per meter square. For convection 1, entities 32 phase, convection coefficient is 5.03 watt per meter square Kelvin. Time variation of temperature variation of for bulk ambient temperature 303 Kelvin. For time variation of. For the properties, name 1060 alloy, model type linear elastic isotropic, default failure criterion max von Mises stress. For thermal conductivity is 200 watt per meter Kelvin. For specific heat equal to 900 joule per kg Kelvin. For mass density 2700 kg per meter cube. For the temperature, minimum is 76.5 degrees Celsius, not equal to 1. For maximum temperature is 97.1 degrees Celsius, not equal to 120.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for this simulation of drawing number 2, okay, for the first one, load is heat power entities in one phase using the heat power value which is 50 watt. Okay, for the second one, convection entities, 50 faces, which consists of 50 numbers of the cylinder inside. The convection coefficient, which is 5.03 watt per meter squared Kelvin. For the bulk ambient temperature, which is 303 Kelvin. Okay, next, which is the heat flux. The heat flux consists of 25 phases with the heat flux value is 1500 watt per meter squared. Okay, for the temperature one, entities 25 phase, we get 349.6 Kelvin. Okay, for the next one, temperature 2, which is consists in one phase, use and get temperature in 370.3 Kelvin. And okay, this is the properties of the material. The first one, name 1060 alloy, model type linear elastic isotropic, max von Mises stress, thermal conductivity, which is 200 W per m dot K, specific heat 900 joule per kilogram Kelvin, and mass density is 2700 kilo per meter cube. For the component, we use solid body, 1L pattern. Okay, for the last one, this is the real simulation of our drawing. So the minimum temperature that we get is 76.5 Celsius. For the max is 97.1 Celsius.
Hello, my name is Afiq Hamizan bin Syaharudin. Okay, so for conclusion, I divided into 3. Firstly, for the drawing. The pin are more difficult than the fin because in the pin, we need to draw 25 holes and need to be centered one after another. Then the fin only 10 are be drawn. And then for the simulation, we can conclude that the fin are spread better temperature than during the forced convection because the fin are wider surface area than the pin. Furthermore, the pin has a small thickness and also help disperse heat quicker than the pin. And lastly, for the conclusion of this assignment, we can conclude that we'll be able to fulfill all the requirements that lecturers needed. After that, we learn a lot of new things such as drawing and performing a simulation in software that called Solidwork. And lastly, we'll be able to complete this task in teamwork with all the team members giving full commitment. That's all. Thank you.